Welcome to Study Loop.
This is chapter 21, problem number 70. We have a variable capacitor in the tuner of an ham radio. The capacitance is given to us as 2800 picofarads, and the corresponding frequency is 580 kilohertz. And we're asked to calculate the capacitance, the new capacitance, at a frequency of 1600 kilohertz, right? So first thing to remember, the inductive reactance and the reactance of the capacitor equals 0. The resonant frequency, then, you can use the equation 21-19 given on your textbook as the resonant frequency equals 1 over 2 pi squared of 1 over L times C. Now, if we write this equation for the case where we have 1600 kilohertz of frequency in order to calculate C2, let's see how that's going to turn out. So F2 is going to be equal to 1 over 2 pi square root of 1 over L C2. Well, we don't know what L is, so we cannot directly use this equation to calculate the capacitance. Instead, let's write the same resonant frequency equation for the first case where we have F1 equals 1 over 2 pi square root of 1 over L C1. So let's take the square of both sides. F1 squared is going to be equal to 1 over 4 pi squared, 1 over L C1. Right? Now, if I multiply both sides by C1, then I know what this constant on the right-hand side is. So here, C1, F1 squared is going to be equal to 1 over 4 pi squared times L. Now, let's take the square of this first equation as well. Then F2 squared is going to be equal to 1 over 4 pi squared times L times C2. Then now we know what this term is, right? In terms of C1 and F1, this equals to, as you see, C1 F1 squared. So if you rewrite F2 squared equals C1 F1 squared over C2. My apologies. Yeah, C2. Now, what we're looking for is actually this C2, right? So if we multiply both sides by C2 and divide both sides by F2 squared, then what we're going to have is C2 equals C1 F1 squared over F2 squared, right? So this is the equation that we're going to use to calculate the second capacitance. Then C1 was 2800 times 10 to the power negative 12 farads, right? And then F1 is 580 times 10 to the power 3 hertz, but we're going to take the square divided by 1600 times 10 to the power 3 hertz squared. Then from here we find the second capacitance to be 368 times 10 to the power negative 12 farads. Well, this is corresponding to 360 picofarads, right? Now, in part B, we're asked to calculate the inductance. So, well, that's going to be pretty straightforward, right? We're looking for L, so you could use either equation, either F1 squared equation or F2 squared equation that we derived previously. So, for example, we could use this one, right? Or this one. So it's really your choice at this point. So F1 squared equals to 1 over 4 pi squared times 1 over L C1, right? So if we isolate L out of this equation, then L is going to be equal to 1 over 4 pi squared C1 F1 squared, all in denominator. Then we plug in the values. So this one's pretty straightforward. 3.14 squared times C1 was 2800 times 10 to the power negative 12 farads, and F1 is 580 times 10 to the power 3 hertz. We're going to take the square of this. Then the inductance is going to be found as 2.7 times 10 to the power of negative 5 henries.